I want you to imagine an intelligence factory running at just absolute breakneck speed.
Right.
The kind of operation that has been churning out innovation so fast, it is, almost impossible to keep track of. Just to put a number on it, in the first 90 days of 2026 alone, the industry dropped a record-shattering 255 new AI models.
Which is just an absolute avalanche of new capabilities.
It's staggering.
Yeah.
But then, on March 28th and 29th, the entire pipeline went completely eerily flat.
Yeah, total silence.
Right. For 48 hours, not a single major release. So today, our mission in this deep dive is unpacking why that silence was definitely not a vacation.
Oh, no.
It was a calculated ambush, one that triggered a brutal price war right at the exact moment global oil markets are, threatening to pull the plug on a whole operation.
It really is the perfect storm.
Okay, let's unpack this, because the 48-hour lull we just witnessed across our stack of market digests, it was the perfect cover for a massive disruption, wasn't it?
It was. I mean, it's the classic calm before the storm. To understand the magnitude of what just happened, we have to look at March 27th, literally the day right before the industry went quiet.
Right.
That was when Luma AI launched its Uni 1 foundational model. And what makes this so critical is that, Luma is a relatively smaller player compared to the massive incumbents in the space.
Sure.
Yet Uni 1 reportedly outscored both Google and OpenAI on standard performance benchmarks.
Which, beating the incumbents on benchmarks is a massive technical flex on its own, especially considering how steep the curve has gotten lately.
Oh, absolutely.
But looking at the market snapshots, the performance isn't the actual ambush here, is it? The real weapon is their pricing strategy.
Exactly. They launched Uni 1 costing up to 30% less than those established giants.
30%? That is huge.
It's a total paradigm shift. Luma isn't just releasing a model. They are deliberately undercutting the entire economic foundation of the AI space. And the timing is everything here.
Right, because of Q2.
Yes, exactly. We are heading right into Q2. And in the corporate calendar, this is the exact window when massive enterprise customers at, Fortune 500 companies, major tech firms, they are locking in their annual software budgets right now.
Making those big bets.
Right. They are deciding which intelligence provider they are going to rely on for the rest of the year.
It makes me think of a heavyweight boxing match,
Huh. Yeah, that's a good way to look at it.
You got these absolute giants swinging wildly at each other for months, just trying to claim that frontier model crown. And they finally clinch, right? They pause to catch their breath after that 255 model blitz.
Right, they're exhausted.
Exactly. And right at that exact second of exhaustion, a lightweight sneaks into the ring with a steel folding chair.
Yeah, completely blindsided them.
Luma swinging the hardest right when the giants pause to secure those Q2 enterprise contracts. It's just a brilliant strategic move. But it begs a massive question for you and me looking at this.
What's that?
Well, Luma offering a 30% discount tells me one of two things. Either they are setting piles of venture capital on fire as a loss leader just to, steal market share, or, and this is the big one, they have fundamentally solved the compute cost problem under the hood.
Right.
And given the trends we saw in Q1, I am betting heavily on an architectural shift. Am I off base there?
No, your instinct is spot on. They are not just burning cash to subsidize the cost. That wouldn't be sustainable. They are leveraging a fundamental change in how these neural networks operate.
Okay, tell me more.
So the engine making this whole price war possible is something called mixture of experts, or MoE architecture. That is the actual secret to offering elite performance at such a massive discount.
Okay, I'm going to make sure we make this crystal clear for you listening. Let's step away from the technical jargon for just a second.
Good idea.
Think of a traditional AI model, a dense model, like a massive, sprawling hospital. In the old days, meaning, last year, if you walked in with a simple sprained ankle, the hospital protocol required every single doctor in the building to examine you. The neurosurgeon, the cardiologist, the oncologist, all of them had to look at your ankle before you could get a bandage.
Right, which is completely wild to think about.
Exactly. The systemic cost, the time, and the energy required for that approach were completely unsustainable.
That captures the inefficiency perfectly. Activating the entire parameter network for a simple, basic prompt is a massive waste of compute.
Yeah.
So what a mixture of experts architecture does is, to use your analogy, it installs a highly efficient triage desk right at the front door.
Oh, I like that.
When a prompt comes in, a routing network analyzes it and sends it only to the specific expert subnetworks that were trained to handle that specific type of query.
So the cardiologist stays asleep.
Exactly. The cardiologist doesn't even wake up. To put hard numbers to this, look at the data we have on NVIDIA's Nemotron 3 Super, which shipped right in the middle of March.
Right, that was a huge release.
Huge. The model itself contains 120 billion parameters in total. But when it runs an inference, when it actually answers a prompt, it only activates a 12 billion parameter budget.
Wait, really? It's only using 10% of its total capacity at any given millisecond.
Just 10%.
That is an incredible reduction in overhead.
And here is the kicker. The performance doesn't suffer at all. Despite using a fraction of the compute, Nemotron 3 Super holds a massive 0.8 GPQA score lead over its competitors.
Which is not an easy test.
Not at all. For context, GPQA stands for Google Proof Q&A. It is an incredibly rigorous graduate-level reasoning benchmark. It covers physics, biology, chemistry.
Hard stuff.
Yeah, it's designed to be so difficult that human experts with full access to the internet still struggle to answer the questions.
Wow.
So you have a model using 10% of its active parameters, running far cheaper, and still demonstrating elite graduate-level deductive reasoning.
And we are seeing the ripple effects of this efficiency war everywhere now, especially in the open source community.
Oh, totally.
Like, if we look at Mistral Small 4, it is gaining huge traction, not just because it's cheap, but because it offers a 256,000 token context window as a standard open weight feature.
Which is huge.
It is.
Yeah.
Now, I know OpenAI's proprietary GPT 5.4 is pushing a 1 million token context window, which is astounding, sure. But the fact that 250,000 tokens is becoming the baseline standard for the smaller guys, that is wild.
Yeah, it really changes the game.
It means you can feed the model hundreds of pages of documentation, financial reports, entire code bases, legal libraries all at once. The sheer volume of data you can process in working memory is just exploding,
Right.
while the cost to process it is plummeting.
Which brings us to the practical application for you, the listener. Because this mixture of experts architecture and the resulting plunge in inference costs means these incredibly capable models can now run on much smaller, significantly cheaper GPU clusters.
So you don't need a supercomputer.
Exactly. The barrier to entry for enterprise deployment is just collapsing. The timeline for you to adopt, experiment with, and integrate frontier-class intelligence into your own specific daily workflows just accelerated by years, all because the financial friction has been removed.
Okay, so if intelligence is now practically free and it is highly efficient to run,
Yeah,
what are developers actually building with it?
that's the real question.
Because looking at our technical digests, we have clearly moved way past, making fancier chatbots that just write emails or summarize articles.
Oh, for sure. We are witnessing a wholesale transition from chatbots to conductors. What's fascinating here is that the falling price of inference has birthed a new wave of AI-native tools that do not just wait for a question to provide an answer.
Right.
They actively orchestrate entire multi-step workflows autonomously. They are agents.
The examples in our research stack, they feel like we leaped 5 years into the future overnight. Let's look at Manus, for instance.
Oh, Manus is incredible.
It's an end-to-end AI research agent, and the underlying mechanism is fascinating. You don't prompt it step by step. You give it one single objective prompt.
Right. Just the end goal.
Yeah, and then Manus generates its own internal plan. It spins up a browser, runs the competitive research, scrapes the data, evaluates its own findings to make sure they are accurate, which is crazy, builds the raw data tables, synthesizes everything, and generates a polished, formatted PDF output. It orchestrates the entire reasoning and acting loop by itself.
And that agentic behavior is completely reshaping how we build software from the ground up, too. Take Cursor, for example.
The code editor.
Yeah, it's an AI-native code editor. You aren't just getting smart autocomplete anymore. You literally chat with your code base.
That's so cool.
Under the hood, the AI is indexing your entire software repository as a vector database. It understands how every single file and dependency connects. You just discuss architectural questions with it, and it writes and integrates the modules across multiple files simultaneously. Or look at Zapier agents, where you can build complex multi-step back-end data automations simply by describing the logic you want in plain English.
And I have to mention my absolute favorite from the list, which is Lovable.
Oh, yeah. Lovable is wild.
It operates on this concept called vibe coding.
Wag coding, yeah.
You just write a text prompt describing the quote-unquote vibe and the function of the web app you want, like maybe a project management tool with a dark mode aesthetic and a drag-and-drop interface. And Lovable just generates the functional front-end, the back-end logic, and handles the deployment in minutes.
It's honestly mind-blowing.
But I have to push back here for a second, because this raises a massive structural question.
Okay, lay it on me.
If tools like Lovable can build a functional web application from a feeling and a text prompt, and Zapier can automate the entire backend without you needing to know a single line of Python, does traditional software architecture even matter anymore? Like, are we just making software engineers obsolete?
Well, I wouldn't say we are making them obsolete, we are elevating them. The core skill required to build digital products is shifting drastically.
How so?
The inherent value is no longer in knowing how to write the syntax or memorizing the libraries or, manually typing the code. The value is in the human defining the objective, understanding the complex business logic, and orchestrating the systems.
Oh, okay.
We are moving from imperative programming, where you tell the computer exactly how to do every little step, to declarative programming, where you tell the computer what the final state should look like, and the agent figures out how to get there.
The AI becomes the laborer.
Exactly. The AI becomes the laborer, you become the systems architect. But, and this is the massive caveat, you only get to be the architect if the building materials, meaning the intelligence and the compute power, remain cheap and abundant.
Right. Which brings us crashing into the flashing red warning lights of the physical world.
Unfortunately, yes.
Because while the digital realm is experiencing this unprecedented golden age of cheap, abundant, frictionless intelligence, the physical world powering those servers is under immense and immediate stress. Looking at the broader market snapshot today, the S&P 500 is down 1.67%, the Nasdaq is down 2.15%. The market sentiment index is literally flashing extreme fear.
Yeah, the physical reality is definitely intruding. Let me give you the exact facts on the ground as of today, strictly covering the geopolitical developments.
Okay.
We are on day 28 of the U.S.-Iran conflict. Tehran has launched a fresh wave of missile strikes, and crucially, they have expanded their targets beyond Israel to include Gulf states. Concurrently, President Trump has claimed Iran is begging for a deal, though battlefield hostilities clearly continue.
Okay, and here is where it gets really interesting for the AI landscape, bringing it right back to your tech reality. Because while those military escalations are happening and expanding to the Gulf states, oil has just topped $105 a barrel. So look at this incredible paradox we are sitting in. On one side of the ledger, you have Luma and the open source community triggering a massive race to the bottom in software pricing. Digital intelligence is getting 30% cheaper.
Yeah.
But on the other side of the ledger, the physical reality, the energy cost to power the massive data centers, the supply chain disruptions affecting the physical delivery of server racks and cooling equipment that is threatening to squeeze the hardware side of the equation to a breaking point.
It is a total macroeconomic pressure cooker. You have to remember that massive cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud, they are caught right in the middle of this.
Yeah, they're the ones holding the bag.
Exactly. They're the ones hosting these increasingly cheaper software models, but their physical operating costs are spiking. Data centers consume gigawatts of power. If oil stays above $100 a barrel, the power purchase agreements these data centers rely on just skyrocket.
Because you can't run AI on good vibes alone.
No, you can't. You can't run a mixture of experts model, no matter how architecturally efficient it is, without massive amounts of actual electricity.
Which means someone has to absorb that cost. If the physical supply chain remains disrupted and energy costs continue to climb, those big cloud providers will inevitably be forced to pass those rising overhead costs onto the consumer.
They'll have to raise the price of compute.
Exactly. Which would completely neutralize Luma's 30% discount.
Yeah, that's the irony.
The software gets cheaper, but the electricity required to rent the GPU gets more expensive.
Yeah.
You end up paying the exact same amount, you're just paying it to a different utility.
It really proves that the digital economy is still inextricably tethered to the physical world.
100%.
You cannot separate the price of generating an AI token from the price of a barrel of oil or the security of a global shipping lane. The margin squeeze on the hardware layer is the great equalizer here.
So this makes me wonder, if running these massive AI models on silicon is becoming geopolitically and physically unsustainable because of these energy costs, where does the frontier go next?
That is the million-dollar question.
I think it goes to the most energy-efficient computer in the known universe, the human brain. And that brings us to our final source today, Meta's newly released Tribe V2 model, because this pushes AI research into entirely new biological territory.
This is a monumental leap in how we think about computing substrates. Tribe V2 is a neuroscience foundation model. To build it, Meta didn't use text from the internet. They trained the model on over 500 hours of functional fMRI data gathered from over 700 different human subjects.
Okay, let's explain how that actually works, because it honestly sounds like magic.
It does, yeah.
An fMRI tracks blood oxygen level-dependent signals. When a part of your brain is active, blood flows to those specific neurons. So where a large language model trains on billions of text documents to learn the mathematical patterns of human language, Tribe V2 trained on the literal blood flow of human brains to learn the mathematical patterns of human thought and perception.
And the mechanism it uses to process that data is just remarkable. It can predict human brain responses to visual and auditory stimuli in a zero-shot setting.
Zero shot is the crucial term here, right?
Right. It means the model doesn't have to be trained specifically on your brain for it to accurately predict how your visual cortex will light up when you see, say, a picture of an apple.
Wow.
It has found the latent space, the universal mathematical translation between a pixel on a screen and the biological algorithm of the human visual cortex.
So it isn't reading your mind in some, sci-fi telepathic way.
No.
It is mapping the universal biological response to sensory input. And the implications of that are staggering. We are watching a fundamental evolution from models that simulate human output, like writing code or drafting an email, to models that directly encode human biology. By understanding exactly how the brain processes sound and vision, Tribe V2 opens up wild possibilities for non-invasive brain-computer interfaces. We're talking about advanced accessibility tools that could allow someone who has lost the ability to speak or type to interact with the computer seamlessly.
If we connect this to the bigger picture, it represents the ultimate interface evolution.
What do you mean?
Well, we started with punch cards, right? Then
Yeah.
we moved to keyboards, then touch screens, then voice prompts. Mapping the brainwaves directly removes the physical intermediary entirely. And unlike the large language models fighting a brutal, undercutting price war right now, these biological models are in their absolute infancy. The value here hasn't even begun to be commoditized.
So bringing all of these massive threads together for you listening, we are living in a moment of extreme, almost dizzying paradox.
Truly.
On the digital side, you are practically being handed superpowers. You have Luma kicking off a structural war that makes frontier AI drastically cheaper.
Yeah.
You have agentic tools like Manus and Lovable running entire autonomous workflows and coding applications from a single prompt. And you have Meta quite literally decoding the biological responses of the human brain. The potential for individual leverage is infinite.
Yeah, it's a golden age.
But then on the other side, the physical reality, the energy grids, the silicon hardware, the global supply chain, all of that is buckling under immense, terrifying geopolitical pressure.
And that paradox leaves us with a critical question to consider moving forward.
What's that?
If physical energy and silicon supply chains are becoming our biggest bottlenecks, but models like Tribe V2 are proving we can mathematically decode the human brain, which is an engine that runs on roughly 20 watts of power, by the way, about the same as a dim light bulb, are we looking at a future where the AI industry stops relying on massive, power-hungry data centers entirely? The ultimate endgame might not be making silicon more efficient. It might be shifting to biological computing substrates that mimic the hyper-efficiency of the mind itself.
What an incredible thought to end on. The intelligence factory is getting smarter, but the future might not look like a factory at all. Something to mull over the next time you drop a prompt into a model and get a genius answer for a fraction of a cent. Thanks for joining us for this deep dive. We will be back soon to unpack whatever comes next.